Okay, so let's take a look here at section 7.1. We're going to start solving systems of equations. We're going to do it first by graphing. So 2 steps to do this, kind of straightforward. We'll see some problems with this method. I really like the methods. We'll see in the next 2 sections a lot better. But this is going to give us a nice little intuitive feel for what's happening when we solve systems. Step 1, graph both lines. Step 2, the intersection is the solution. So if you can find the intersection of the 2 lines, you have your solution. So I have here 2 lines. I have x plus y is equal to 1 and 3x minus y is equal to 6. Now, let's get started. For x plus y is equal to 1, I elected to make a table of values. Remember, you can pick any number you want to plug in to do this. I like using 0. I find 0 to be very nice. If I plug in 0 for y, put that right there, x is going to have to be 1. And same thing if I plug in 0 for x, y will have to be 1. So that's our first line. We get 2 ordered pairs. We get 1, 0, and the ordered pair is 0, 1. 2 points. I make a line, and it looks pretty good. Seems all right. Let's do the other line. 3x minus y is equal to 6. For this one, I wanted to graph it using slope-intercept form, so that's what I did. Remember, to have slope-intercept form, y has to be all by itself. So you'll notice I subtracted 3x. That's how I get from this positive 3x on the left to moving it over and having a negative 3x on the right. And then since I still had a minus sign for my y, I just divided everything by negative 1. That gets rid of the negative on my y, makes a positive 3x, a negative 6, and there's my second equation. Now this is in slope-intercept form. So remember, for slope-intercept form, the negative 6 here is my y-intercept, and the 3 is my slope. So you'll notice, and this is the line here in red, if you can see the color, down at negative 6, I get a point. There's my y-intercept. And since my slope is 3, remember 3 is the same as 3 over 1. And since slope is rise over run, we go up 3 and over 1. So I go up 3 from that point and over 1, and I get a second point. So now I'm looking for the intersection, and on my graph, it sure looks like it's at positive 2, negative 1. Okay, and so here's the thing though. A solution for a system of equations is any ordered pair that makes both equations true. That's why we're looking for this intersection, because any point that's on both lines, hence the intersection, is a solution for both equations. But here's the problem. This point should work for both. If you plug it back in, it works just fine here. 2 plus negative, right, if x is 2 and y is negative 1, 2 plus negative 1 does equal 1. No big deal there. But if you come over here and you plug it in, 3 times 2 is 6. 6 minus negative 1. Remember, that's like adding 1. So 6 plus 1 should be 7. That's a 6. So what happened? Why did I not get a point that actually works? Well, the long and short of it is, it's really hard, especially if you don't have graph paper, to make a graph where you hit that point where the intersection is perfectly. So a lot of times it's really easy to get an answer that is very, very close to the correct solution, but not exactly right. And so that's why I'm really not a big fan of this method, because you can miss. You can do everything right, and just because you can't draw perfectly, you can miss. So we're going to look at 2 more quick examples, but that's basically how this works. You're going to graph both lines, find that point of intersection, and we'll go from there. All right, let's look at some more. All right, so here are my last 2 examples, and these ones end up being a little bit strange. Here we have y equals x minus 3 and y equals x plus 2. I did them both using slope-intercept form. So this one has a y-intercept of negative 3, has a slope of 1. So if I went up 1 and over 1, 2 points, I made a line. The second one has a y-intercept of 2, and again it has a slope of 1. So I go up 1 and over 1, and you'll notice these 2 lines never meet. These are what are called parallel lines. If they never meet, you can't have a solution, because the solution is always the point of intersection. For the other one, I have y equals 2x minus 3 and 2y plus 6 is equal to 4x. So This one's in slope-intercept form. Its y-intercept is -3. Slope is 2, so I go up 2 and over 1. 2 points, I make a line. But if you come over to this one and run my math through, you'll notice that we get the same y-intercept, 0, -3, by plugging in 0 for x here. And then the second point would be 3/2 and 0. If you plug in 0 for y, you get 3/2. That's right about there. And guess what? These two lines are exactly the same. When you have the same line, you have infinite solutions because every single point on those lines is a solution. So good luck. And don't worry, we have better algebraic methods coming in the next two sections. And those are really going to be where we're going to spend our time.